Average value, okay, on your test, I was looking if you knew how to write the formula for average value. That's what I was looking for. If you never wrote anything that had to do with average value, you did not get any points for this on your test, okay? So average value looks like this: 1 over b minus a, the integral from a to b of f of x dx. If you want the average value of f of x, you put f of x here. If you want the average value of f prime, you would put f prime here. Whatever you put here is what you want the average value of, okay? And then you figure out what your A and B are. So this is your A and this is your B. If you never put any sort of average value formula, then you got the whole thing wrong. But if you plugged in correctly, you got 50% of the problem right. So if you wrote this, 1 minus negative 2 from negative 2 to 1 of 8x cubed minus 2 dx, this was 50% of the problem, okay? If you just showed me that you knew how to plug in to the average value formula. And this is basically how AP grades. Like if you can plug into a formula, you've got most of the problem. What else was I going to say about this? I think that's it. If you didn't have this, if you didn't have at least this, you got nothing. Okay. All right. So this is going to be 1/3 the integral from 8x cubed minus 2, and you want to take the integral of this. Okay. So guys, when you take the integral, okay, you want to ignore the negative 2 and the 1. You want to ignore the limits first. Okay. So you just want to take the integral here of this blue part. So guys, can someone tell me what kind of problem is this integral right here? 8x cubed minus 2. How do I do that? Is it a u sub? Oh boy, do you feel it welling up inside of you? All right, so this is an oh boy problem. 2 easy antiderivatives. So 8, so you add 1 divided by 4. So this would be 2x4 minus 2x from negative 2 to 1. Okay, when I'm done with this, I'll multiply all of it by 1/3. But first, do this first. The 1/3 is being multiplied by all of this. Okay, so first you're going to plug in the 1. Guys, if you plug in the 1 first, what do you get? Plug in the 1. Do you see you get 2 minus 2? Okay, you still need to write it. Even though it's 0, you still need to write it. Okay, then plug in the negative 2. What's negative 2 raised to the 4th power? Negative 2 times negative 2 times negative 2 times negative 2. What is that? Positive or negative? Positive what? 16, right? So that's going to be 2 times 16. 2 times 16. Let me write that. Minus, okay, 2 times negative 2. Do you see that? I'm plugging in the negative 2. Okay, first you plug in the 1. Then you plug in the negative 2. Then you do what, guys? Then you slap a minus sign. But make sure you understand, there are 2 terms here. So when you slap a minus sign, it's minus this whole thing on the right. It's not just minus this first term. It's minus the whole thing when you plug in negative 2. All right, so that is going to be multiplied by 1/3 when you're done. Okay, this is super important. The reason I'm saying leave that 2 minus 2 is this is 0 minus. If you don't leave it, you won't put this negative sign. Okay, so you need this negative sign here. It's actually very important. This is going to be 32 plus 4. Do you guys see negative, negative? Okay, that's going to give you a 4. When you're done, you're going to multiply this whole thing by 1/3. What's 32 plus 4, guys? 36. So this will be 1/3 times negative 36. And so that answer is negative 12. Did you guys get negative 12? Okay, so that is how you do average values. Okay, all right, let's go to homework from last night. So what homework questions did you have? Let's look at it. Do you guys need help on number 2? Okay, so let's look at number 2. All right, there's lots of different ways to do this. If I do it one way and you guys see that's easier another way, can you stop me and tell me how you did it? Because it is a little bit time consuming. It's actually good practice though on lots of different things here. Okay, so I'm given position and I want velocity. Okay, so am I going to take the derivative or the integral? Position given velocity, or PVA, position to velocity. What am I doing? Derivative or integral? Derivative. Okay, guys, you need to figure out if you're going to do derivative or integral now. Okay, so if this is the derivative, I'm going to take the derivative of x to get x prime. Is everybody good with that? Okay, so let's do x prime. This is going to be the derivative of the first times the second minus. Okay, Kaylee, have you done this already? Okay, just making sure. Minus times the derivative of the second times the first. You guys with me so far? Derivative of the first times the second minus derivative of the second times the first. All over what, guys? The whole bottom. Take the whole bottom and square it. All right, that is your answer. That is the velocity at time t. Okay, if you wanted to simplify a little bit, I'll get 1 plus t squared minus 2t squared over the quantity 1 plus t squared squared. And this right here, do you guys see this is really just 1 minus t squared, right? So my x prime, if I simplify it, is 1 minus t squared over the quantity 1 plus t squared quantity squared. And I don't really want to do anything with the denominator because it'll just be foiled, and I don't really, foiling isn't going to help me to do anything, okay? All right, and then it says find the velocity at 2 seconds, okay? So all I do is take this same thing and plug in everywhere there's a t, I'm going to plug in 2. So 1 minus 4 over 1 plus 4 quantity squared. Did you guys get negative 3 over 25? Did you get negative 3 over 25? Okay, I want to show you guys something though. Your calculator cannot do this, but your calculator can do this. What your calculator can do is take the derivative of x and plug in 2. Does that make sense? Your calculator can get the negative 3 over 25, but your calculator can't do this. So just wanted to show you guys that. So like if I went to math 8, right, isn't that derivative on my calculator? And I put in here, okay, I put in here x, and I take the derivative of this t over 1 plus t squared. Guys, look at this, what I learned. Check this out. Alpha y equals. That is the best thing. That's the best thing I learned this year. I got to tell you. Okay, so this is t over 1 plus t squared. So that's really x over 1 plus x squared. Okay, and then right, I want to take the derivative of this, but I want to plug in 3. Okay, now if I plug in x, your calculator isn't going to, it's just going to get stuck. But if I plug in 3, it'll give me negative 3 over 25. I can check it out, right? 3 divided by 25. Oops. Divided by 25. Is that 0.08? Hopefully it is. Oh. Sorry, I plugged in the wrong number. That was supposed to be a 2, right? Okay, back to the drawing board. How do you get back up there? Can I just go up there like this and hit enter? And then go down? Then how do I go back to the 2? Like that? Okay, that's what I want. I want 2. I plugged in the wrong number. Okay. You know, it's because I forgot to pray. Okay, pray, hit enter. That's not right either. It is? Is 3 divided by 25 that? Oh yeah, you're right. It is the same thing. Okay, I just remember something really short. Okay, yeah, it basically is the same thing. So, so that's another way to do it if you have a calculator. Okay. All right. So let's go down here. Next question: when is the particle at rest, and when is the particle going to the right, and when is the particle going to the left? Well, first of all, when the particle is at rest, tell me what's 0. Is it position, velocity, or acceleration? It's velocity. So what I'm going to do is I'm going to set velocity equal to 0. Guys, where is velocity up here that I have velocity? You see, it's this thing right here, right? So I'm going to set x prime equal to 0, which is 1 minus t squared over 1 plus t squared equal to 0. Now, when you set something to equal to 0, I need you to understand this. This is super important. 0 is not the same thing as 1 over 0. You guys good with that? So you can't plug it, you can't say 1 over 0. That's not 0. 0 is the same thing as 0 over 1. Do you agree with that? That's okay. This is okay. 0 is not the same thing as 0 over 0. Is everybody good with that? 0 over 0 is, oh, gotta do something else. 0 over 0 is not 0, okay? The other thing is 0 over 212 is actually the same as 0 over 1, believe it or not. It's the same because they're both equal to 0. You guys good with that? So I always choose, when you set a fraction equal to 0, I always choose 0 over 1. But if you're feeling, I don't know, like a wildcat, you could actually put 0 over 212 and you would get the exact same answer, okay? You would just actually lose some of your life, some time in your life. That's it, okay? But that's small compared to having lots of school spirit, right? Okay, So what you would do here is you would cross multiply. I'm going to change it back to 1. Okay, you would cross multiply. So if you cross multiply, do you see I get 1 minus t squared is equal to 0? Okay, and then what you'd get is 1 is equal to t squared. So t is plus or minus 1. If you go to the very, very top, your t has to be what? Greater than or equal to 0. Okay, so then you just say t is equal to 1. You guys good so far? Okay, that's when my velocity is 0. Okay, when am I moving to the right and when am I moving to the left? Well, guys, when I'm moving to the right, what is my velocity? We talked about this yesterday. Positive. When I'm moving to the left, what is my velocity? Negative. So I just want to get a number line with plus, 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 minus, minus, minus. Does that make sense? Figure out when my velocity is positive and when my velocity is negative. Well, to do that, I need a velocity number line. Okay, it's also the same thing as an x prime number line. Okay, and so my velocity, when is my velocity equal to 0? Remember, you always put your critical values in here first, your critical points. Okay, so when is my velocity equal to 0? When time is what? 1. Okay, so then you need to pick numbers to the left and right, and that's when I'll get plus, 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 or minus, minus, minus. What's a good number? Oops, what's a good number to the left of 0? I'm sorry, to the left of 1? 0. What's a good number to the right of 1? 2. I thought you were going to say 212. Okay, so then you're going to plug into velocity. So where is my velocity function? Where is it? Okay, be careful. This is not velocity because I lost the bottom part of velocity. Do you see that this is velocity? Is everybody good with that? That is velocity. So you're going to plug into here. If you plug in 0, you're going to get 1 over some positive number. So that's going to be positive. Do you guys see that this bottom is always positive? Because it's squared, right? So it's always going to be positive. If you plug in 2, what do you get? 1 minus what? 1 minus 4. Is that positive or negative? Negative. So you're going to get a negative number over a positive number, and that's going to be negative. All right. So if x prime is positive, x is increasing. If x prime is negative, x is decreasing. Okay. When is a particle moving to the right? Guys, when am I moving to the right? When t is between what? 0 and 1. When is velocity positive? When t is between 0 and 1. Wipe out, actually, I guess I should really wipe out this 0 and this 2. But my time is between, is greater than 0 anyway, so I'll just put the 0 there. If you said t is less than 1, I would still count it right. And I feel like most graders would count that right. Okay, what about when v is negative? When is v negative? You guys good with that? What's my justification? What's my justification for saying t is greater than 1? Oh, it's already here. It's because velocity is negative. That's when you're moving to the left, because velocity is negative. And here you'd say because velocity is positive. Or instead of velocity, if you're trying to get fancy, you could say x prime. X prime is positive, or you could say x prime is negative. It actually means the exact same thing. All right, you guys good with part B? Okay, you guys ready for the Whopper? Nope, that's not the Whopper. The Whopper is part E, I think. Okay, find the displacement. Guys, what's the formula for displacement? All of calculus is formulas, okay? What's the formula for displacement? X final minus X initial, okay? My X final is going to be X at what time? 4. My X initial is going to be X at what time? 0. Can you find X at 4? Sure you can. Here's X, right? Everywhere there's an X, you're going to put, everywhere there's T, you're going to put 4. So do you see that that's 4 over 17, right? Okay. Can you find X at 0? Sure you can. Everywhere there's a T, what are you going to put in? 0. So this is 0, 0, 0. What's 0 over 1? 0. So your answer is 4 over 17. All right, total distance. Now with total distance, we have 2 choices now. We can do a Canada's test, or we can plug into the velocity formula that we have, okay? So let me go ahead and do a Canada's test first, because I'm pretty comfortable with it, and then I'm going to plug into the velocity formula, and I'll just see if I get the same thing, okay? For total distance, you're going to do a Canada's test with t and x of t. First, you're going to put in the endpoints. What are my endpoints here? All right, so put them in, 0 and 4. Okay, when when you put in the endpoints, there's something else that you put in here besides endpoints. What are they on a candidate's test? Critical points. Okay. How do you find the critical points? This is very key. Yeah, you look at whatever is here, whatever function here. Your function here could be anything, okay? But you look at this function, you take the derivative of that function, okay? And then you set that equal to 0, all right? But you notice that that really is v, right? So v is equal to 0. So guys, what t values gives me v is equal to 0? I did that before. What was it? Was it just 1? That's it? Okay, so you're going to put in your critical points, which means you set this derivative equal to 0, solve for t, and your endpoints. Then you just fill in this chart. Okay, but guys, am I going to plug in v or am I going to plug in x for this chart? X. So go find your x. Okay, my x was way up here. My x is t over 1 plus t squared. So first you put in a 0, and do you see you get 0? Then you put in a 1. Okay, what do you get if you plug in a 1? Oh, nice, 0.5. And then put in 4. Oh, we did 4 already right here, right? 4 is going to be 4 over 17. Okay. Then you pick the largest number. Actually, I don't know what 4 over 17 is. Okay. So guys, oh, I don't pick the largest number. Sorry, that's not what I did. I'm doing total distance. I was doing max or min. How do you get total distance? What's the distance between 0 and 0.5? Okay. What's the distance between 0.5 and this 0.2 thing? I don't know. Just put it in your calculator. So it'd be 0.5 minus 4 divided by 17. And it doesn't matter if it's negative or positive. You're just going to get the distance. So you're going to get the positive number. So 0.2647 when I subtract those. And then do you see you just add these numbers together to get the total distance. So plus 0.5. And so my answer is going to be 0.764 or 0.765. Notice I never rounded until the very end, okay? Actually, even though I put this number rounded, I didn't round it when I actually calculated it. Okay, the other way to do total distance is you found a new formula. Remember, it's the integral of the absolute value of your velocity formula dt. Guys, this must be a formula. It cannot be a number, okay? You can't plug in a number here. It's got to be a formula. Okay, so it's going to be the total distance from, this is a t, so time 1 to time 2. What are going to be my times on? 0 to, I need another time, 4, okay? What's my velocity? Do you remember I found that over here somewhere? My velocity is 1 minus t squared over 1 plus t squared squared, okay? So this is going to be 1 minus t squared over 1 plus t squared squared, absolute value dt, okay? If I put this in the calculator, if I did this right, I should get the same thing. Did anybody do it this way? You did? Did you get the same thing? Nice. Okay, just FYI, you can do it either way, whatever floats your boat. Okay? Just don't forget the absolute value signs. All right, let's go to letter E. Find the acceleration. Now, this is where it gets fun. Okay, find the acceleration at time t, and then find the acceleration at time 3. Now, I want to point out to you guys, if you know velocity, so I know velocity, and I'm asked for acceleration at a certain time, I can put that straight into my calculator. So I think on your homework last night, I don't know if I have your homework here. Yeah, on your homework last night, on number 4 on your homework, you're given velocity and you're asked for acceleration at time t. Do you see? That's a math 8 straight into your calculator. Is everybody good with that? So hopefully you saw that. Otherwise, you're doing a lot of work. But if you did the work, you should get the same answer. Now, finding the formula for acceleration, though, your calculator cannot do. So calculator sad face. Okay, your calculator can't do that. But your calculator certainly can do this part. All right, so let's go ahead and find the double acceleration here. Okay, so, oh, what number am I on? Am I on number 2? Okay, I wonder if I need, is that the last problem? Oh no, I also need speeding up and slowing down. Okay, so x double prime is going to be equal to the derivative of the derivative of x. So it's going to be the derivative of this. So here we go. It's going to be the derivative of the first times the second minus the derivative of the second. That's just chain rule. It looks terrible, but it's just chain rule. 2 times 1 plus 2 squared take the power down by 1 and multiply by the derivative of the inside. Derivative of the first, Sarah, you got this on your paper? Times the second minus derivative of the second, okay, that's just chain rule, times the first. Oh, I was hoping that would be in a different color, but it's not. Let me see if I can get it into a different color. Derivative of the, oops, now it's all messed up. Okay. So this is going to be times the first. Derivative of the first times the second minus derivative of the second times the first. Okay, all over the whole bottom. Okay, that's already the bottom. Then I'm going to square the bottom. What's a power to a power going to be, guys? You multiply, right? So you're going to multiply those. All right, so on the top here, you can simplify a little bit. How many of you guys distributed this whole thing and got it? Okay, did you guys simplify this at all? You can pull out some common factors. Let me pull out, see, do you see they both have 2 t's? And they both have 1 plus t squared. So I can actually pull out 2t and then also pull out 1 plus t squared. Like pull it out like a factor. So if I pull that out, look at the first term. What would I have left? I pull out the 2t, so I'd have a negative left, right? I pull out one of these 1 plus t squared, so I have one of these left. So that's the first term. If I remultiply this, I should get the first term. And then the second term, okay, I'm going to leave the negative. I'm going to pull out the 2t, so I have a 2 left. I'm going to pull out one of these 1 plus t squared, but there's only one, so I'm going to pull this whole thing out. And then I'm going to have left this 1 minus t squared. Okay, so that's just, I'm just factoring out the top, okay? Why am I factoring out the top? Because I'm thinking it's going to help me in the future. The bottom is just 1 plus t squared raised to the 4th, okay? I want the acceleration at time t. Oh, this actually is, well, I'm just trying to simplify it. This is actually the answer. This is the acceleration at time t, okay? But I think I'm going to try to simplify it a little bit more. And the way I simplify is this. I have 2t, 1 plus t squared. In the parentheses now, though, I have, I'm going to distribute this negative, okay? So if I distribute the negative, I have negative 1 minus t squared minus 2 plus 2t squared, okay, all over 1 plus t squared raised to the 4th power. There's lots of things you can do here. I'm going to go ahead and just simplify what's in here. This will be 2t times 1 plus t squared times, in the parentheses, I have negative 3 plus t squared all over 1 plus t squared to the 4th. And that's my acceleration. Okay. Did anybody cancel these out? Yeah, so I canceled them out. So there's one of these up here and one of these down here. Do you see that? So this is actually 2t, and then just switch these places. 2 squared minus 3 over 1 plus t squared raised to the 3rd. Okay, and that's what I have on my answer, it sounds like. It'd still be right. Yeah, actually I didn't in the last class. Nobody said anything, so it's fine. Okay, so this is x prime. Okay, and then if I wanted x prime at 3, so x prime at 3, you could substitute it in here. So that'd be 6 times 9 minus 3 over 1 plus 9 raised to the 3rd power, which is 6 times 6, which is 36 over 1 plus 9 is 10. I think that's 1,000. Okay, which is 0.036. This is kind of interesting though. Remember what I told you? This answer here you could have gotten in the calculator. So I don't know if anybody did in the calculator. Actually, is this right by any chance, 0.036? Okay, you got it in the calculator. Yeah, so you could just go into the calculator and get the second answer. But the first answer with t's you had to do by hand. All right, the next thing they ask you is to compare acceleration and velocity and figure out when you're speeding up and when you're slowing down, okay? I need this formula. I'm gonna grab this formula. So this is my acceleration. I need to copy that somehow. Copy. Okay, so I'm gonna go to the second part here. And I have my velocity there, but I also need my acceleration. So let me paste my acceleration in here. Okay, so there's acceleration, there's velocity, there's position. All right, and they're asking me, use your calculator, figure out when you're speeding up or slowing down. You could actually just graph these things in your calculator and figure out when you're speeding up and slowing down. But let me just do it by hand. If I have velocity, guys, when was velocity 0 in this problem? When was velocity 0? Was it just 1, that was it? Okay, and then what you do is you do the same thing for acceleration is 0. When velocity was at 1, was it positive on this side by any chance and negative on this side? Was it like that? Okay, so I'm just going to copy that graph. I need to make the same graph for acceleration, basically. Okay, and so you can actually just put this in a calculator if you want to. But what you do is you set this thing equal to 0. So you set your acceleration, which here's my acceleration. Just like I did with velocity, I'm going to set it equal to 0 over 1. Then you cross multiply. And so what you get is 2t times t squared minus 3 is equal to 0 when you cross multiply. So you get something times something equals 0. I'm setting my acceleration equal to 0. Something times something equals 0. That means 2t is equal to 0, or t squared minus 3 is equal to 0. That means t is equal to 0, or t squared is equal to 3, or t is equal to plus or minus square root of 3. But remember in this problem, I only need t to be, see, here's my 0. Here's my square root of 3. Square root of 3 is bigger than 1. You kind of line this up. And I also have a negative square root of 3. But it doesn't matter because I'm not looking at less than 0. Okay? So then I need to go positive or negative, positive or negative. So let me get a number here and a number here. What's a good number between 0 and square root of 3? Like 1. What's a good number greater than square root of 3? 2 or 4. Yeah, 4 is fine. Okay? So then what you do is you plug into your acceleration. My acceleration is right here. That is my acceleration. So plug 1. I just need to know positive or negative. So if I plug 1, do you see that's going to be positive times negative, right? 1 minus 3 is negative. So it's going to be positive times negative divided by, if I plug 1 here, do you see 1 squared is going to be positive? So divided by positive. So what's that going to be? Negative. So this is going to be negative right here. And then bigger than square root of 3, and then ignore the 1, I don't need it now. Then bigger than square root of 3, I'm going to plug in 4. So that's going to be 2 times 4, which is positive. If you plug in 4 here, you get 16 minus 3, which is positive. And if I plug in 4 here, it's going to get squared anyway, right? So that's going to be positive. So do you see if you plug in 4, you're going to get a positive number. You don't really need to know the number. You just need to know positive or negative. And so what you do is remember, you're speeding up when acceleration and velocity have the same signs. So compare these graphs. When do you have the same signs? And you just need to compare bigger than 0. So when do you have the same signs? Actually, right here is where I have the same signs. You see it? Right? Between 1 and square root of 3, velocity is negative and acceleration is negative. Okay, so that's your answer. Speeding up, okay, when t is between 1 and square root of 3. What's the justification? Because velocity and acceleration have the same signs. And notice I only use the key words. You don't have to put all those middle words in there, okay? And then let's do slowing down. Okay, slowing down is whenever they have different signs. Okay, so slow down. When does that happen? Between time 0 and time 1. Do you guys see this box right here? Time 0 and 1. When else do you slow down? Yeah, after square root of 3, all after square root of 3. So t is greater than square root of 3. And what's going to be the justification for that? Have different signs, okay? And you're good. You could have also put the velocity function in your calculator, right? And you could have put the acceleration function in your calculator and notice when it was both positive and when it was both negative, okay? That's another way to do that. All right, what other problem on your homework do you need help with? Yeah, that's a great problem to do. This is a problem you might see again. This is a great problem. Okay, what did they graph here? Did they graph speed or did they graph position? Okay, they graph position. If you know position, can you tell me if your velocity is positive or negative? Can you tell me? Because like this, if I move from here to here, from time 0 to 1, do you see my position is increasing, okay? But do you see, I can actually get my velocity here. Do you see velocity, isn't that the derivative of speed? I'm sorry, the derivative of position, right? So if this is position, the slope of this is going to be my velocity. Do you see that? So right here, you can see that your velocity is going to be equal to, there's a lot of ways to do it, but do you see that your velocity is equal to, we have a formula here for velocity, it's equal to the slope of this. And so do you see the slope of this is 2, yeah, 2 over 1. Do you guys see that? I don't know if you see that. It's y over x, right? So this right here is y, and this right here is x. So your slope here, which is your velocity, okay, because it's a straight line, the slope stays the same. This slope, this velocity is going to be 2. So right here, between time 0 and 1, your velocity equals 2. What's my velocity here? What's the slope of this line here? 0. What's my slope here? What's my velocity here? Can you guys get it? What's the y value here? Is it 4? Negative 4. Negative 4 over 1, right? Negative 4 over 1. So what's the velocity here? Negative 4. What's the velocity right here between time 3 and 5? 0, okay? And guys, it's because these are straight lines that we can get the velocity. If they were curves, we wouldn't be able to get the velocity, just FYI, okay? It's only because they're straight lines. And then guys, what's the velocity going to be here? Is it going to be positive or negative? Negative, okay? And so just find 2 points, okay? So this is going to be, actually, if you think about what velocity is, maybe this is easier. It's going to be x at 6 minus x at 5 over 6 minus 5, right? Isn't velocity the change in x over the change in time, right? So the change in time is 6 and 5, and the change in x between those times is x of 6. X of 6 is actually negative 4. X of 5 is actually negative 2 over 1. So this answer is negative 2. Did you guys get negative 2? Okay, so that's negative 2. All right, so let's go answer some questions. When is the particle moving left? Okay, when velocity is positive, you're moving right. When velocity is negative, you're moving left. Okay, what about when velocity is 0? Am I moving left or right? Not moving at all. Okay, so when am I moving left? That's going to be when velocity is negative. So between time what? 2 and 3, do you guys get anything else? 5 and 6. Okay, so those are your answers. And then the justification would be because V is negative. Okay, moving right. So moving right, okay, that's going to be when velocity is positive. So that would be between time 0 and 1. And also between time, oh, just a joke, just 0 and 1. Okay, and what's your justification here? V is positive. All right, what about standing still? Between time 1 and 2, T2, and between time 3 and 5. And what's your justification? Velocity equals 0. You see how nice that is, okay? And then part B, is that when you have to graph your velocity? Okay, well, let's graph this sucker. Between time 0 and 1, so here's 0 and 1, what's my velocity? Yeah, I know, I'm just putting it on here. So between times 0 and 1, isn't my velocity equal to, is it 2? Graph 2. Between time 1 and 2, what's my velocity between time 1 and 2? Is it 0? So graph 0, you're right there. Every point between time 0, between time 1 and 0, you're going to have a velocity of 0. Guys, this is only because we have straight lines, okay? All right, between time 2 and 3, what's your velocity going to be? Okay, so graph negative 4. You're down here at negative 4. Okay, I know mine's not to scale. Okay, what about between time 3 and 4? What are you going to have? 0. Okay, so graph 0 right there. Between time 4 and 5, what do you have? Oh, still 0. Okay, what about between time 5 and 6? Negative 2. So your graph can be like this. If you want to connect it, you can too. So, oops, you got to connect vertical lines. If you want to connect it, you can. Or you can just leave it without connections. It's the same thing. Okay, but that's your graph. Okay, And then you want to graph, this is a graph of velocity, right? What if I want to graph speed? Isn't speed just a positive of velocity? Okay, so which numbers do I need to make positive? Yeah, -4 and 2. Guys, if velocity is -4, what's speed going to be? Okay, so all you do is you wipe out this -4 and you turn it to a +4. Do you guys see that? And that's going to be my new graph. Like, you're going to make this a +4 instead of a -4. And what's the other place I need to change? -2, right? This -2, if you're graphing speed, then it has to be positive. So it can't be -2 anymore. What is it now? +2. And there you are. And you can bring it down if you want to, but there's your speed. Do you guys see the difference between speed and velocity? It's really just the absolute value of velocity. Did we finish this problem? Okay, nice. What other questions do you guys have? Yes. Yes, which number is that? 3? Okay, let's go back to 3, guys. This is a great question. If you're ever asked the maximum or minimum, you need to do a Candidate's test. You knew this at one time, okay, but it might have slipped your mind. So what you need to do is do a Candidate's test. On the left side is a T. On the right side is whatever you're trying to find the maximum of. What am I trying to find the maximum of? Acceleration. Guys, in a Candidate's test, what 2 things go on the left side? Your endpoints. What are my endpoints here? And your critical points. Now, here's what's critical. All puns in this class are intended. Okay, you take whatever is on the right side, and you take the derivative of that, and you set it equal to 0, right? That's how you get a critical point. Guys, if I take velocity, and I take the derivative of that, do I get A prime? What's the derivative of velocity? It's not A prime. What is it? It's A. So do you see you have to take the velocity twice, the derivative twice, okay, which is kind of funky. But what you do is first you take the derivative and you get A. So that'd be 3t squared minus 6t plus 12. And then you take the derivative again because you want the derivative of AT. So that's going to be 6t minus 6. Once I get the derivative of A, what do I set it equal to? 0. This is going to be how you find your critical points. That's how you always do it on a Candidate's test. First you put your x, then you put your y, then you take the derivative of your y and set it equal to 0. Whatever this is, you get the derivative of it. So you end up taking the derivative of velocity twice, which nobody wants to do, okay? But you have to do it. And so then you get 6t is equal to 6, so t is equal to 1. And so what's my critical point? 1. Okay, now when you fill out this chart, what numbers am I going to put in for this chart? B's, A's, or A primes? A's. Okay, so which equation is going to give me A? That one. Okay, so plug in 0, what do you get? 12. Plug in 1, what do you get? Okay. Plug in 3, what do you get? Would you get 21? Okay. Guys, then what you do is choose the biggest number. What's the biggest number? Try again. 21. Do you guys see it? And that's the maximum. If they said, what's the minimum A, you would choose the smallest numbers. Maximum minimums only happen at endpoints or critical points. And that's why we do a Candidate's test. Okay, that's the only times maximum numbers happen in a continuous function. And right now we're working only continuous functions. Okay, you guys ready for a problem for today? So guys, let's go to, oops, that's not what I wanted. Go to today's example. It's on your the front of your homework, I believe, and then you'll just finish the rest of your homework. This should not feel too heavy. We've done this before, okay? And really we're just kind of, you know, sealing everything that you know, making sure that you understand it. So here we go. You have acceleration, okay? And here's the function for acceleration. And you want velocity. You have acceleration, you want velocity. Think PVA. What operation? Antiderivative. Okay. The most intuitive way to do it is actually with Charlie. Okay, taking the antiderivative. You could also do it with the first fundamental theorem of calculus, which I've done with you. But let's just do this because this is going to be the most intuitive, and this will also help you for your quiz. And the first fundamental theorem of calculus will also work. Okay. I want to go to A to V. What did you say I needed to do? All right, let's do it. Antiderivative of the left side. If I do the left side, I also have to do the right side. All right. The antiderivative of A is VT plus Charlie. There's a Charlie here, but what I'm going to do is I'm going to move all the Charlies to the right side. Okay. Let me put a DT here. What is the antiderivative of 6t minus 14? 3t squared minus 14t. Very nice. Don't forget Charlie. Don't forget Charlie, guys. I forget Charlie all the time. Good thing I didn't name my kid Charlie. But anyway, I forget him anyway. Okay, so this is going to be the velocity. This is your answer, guys. It's just you need a number for Charlie. So go back to your initial condition. Do you have an initial condition that will help you with velocity and time that will give you Charlie? Right there. V of 0 is equal to 8. Guys, let's translate this one to Calculus Talk 2. This one is V of 0 is equal to 8. What about this one? S of 1 is equal to 7. Guys, the Calculus Talk is very important that you understand this. All right, so this is going to be, anytime time is 0, your velocity is going to be 8. So you plug this in. Okay, so did you get C is equal to 8? You guys good with that? Now, C isn't always equal to whatever your number is. Just be careful. Okay, so all you do is you cross this out. That's 8. And there is your velocity function. Velocity is equal to 3t squared minus 14t plus 8. Whatever you do, please do not delete your C. Please do not erase your C. You can cross it out. But if you accidentally calculated, if you made a silly mistake and you said this was 7, and you erase this and put 7, then you're done. I can't give you partial credit. Okay, I need to see that you are solving for C. Okay, all right. Then what you want to do is find the position. Well, guys, PVA. Okay, how do I get position if I'm starting from velocity? Antiderivative. So you do the same thing. Pull this equation down here. Okay, take the antiderivative of both sides. The antiderivative of V. What is the antiderivative of V? S. Okay, plus C, but I'm going to move Charlie to the right side. Then I'm going to add 1, divide by 3. Add 1, divide by 2. And then finally I get an 8t. This was to add 1. It's just really messy. Okay. Did you get what I got? Plus C. Nice. Okay, I'm glad you guys are remembering Charlie. You guys will be great parents. Okay, this would be plus C. Okay, but I can't leave C there. Okay, so what do I need to do? Yeah, go find your initial condition, which was up here. S1 is equal to 7. So set your S equal to 7. Set your time values equal to 1. Okay, solve for C. This one's a little bit harder to do. 9 minus 7. I'm getting C is equal to 5. Can I get a check on that from anybody? Okay, 5. So this will be 5 here, and there is my position right there. You guys feeling good about this? Not too bad, right? Next question. Okay, given your position and your velocity, when is my particle at rest? When is my particle at rest? Guys, when you're at rest, what's equal to 0? Is it T, S, V? It's V. So you're going to set V equal to 0. I already know my V. My V is 3t squared minus 14t plus 8. I'm going to set that equal to 0. Okay? You're going to need to solve for your t here. So you're going to need to factor. I think my factors are going to be 3t and t. I need to choose 2 factors for the 8. Let me just choose 2 and 4. And that's 12. Hey, guys, I think this worked out. Hey, I think this is going to work out for me, guys. Okay, so you factor out, and you get 3t is equal to 2. Well, what you get is something times something equals a 0, which means one of these somethings is 0. Either 3t minus 2 is equal to 0, which means t is equal to 2/3, or t minus 4 is equal to 0, which means t is equal to 4, and I think I'm done. Did you guys get the same thing? All right, and then the final part D here is the total distance. And there's 2 ways to do total distance, okay? You can do it the candidate's test way, which is T and X of T, okay? You put in your endpoints, and what else do you put in? Your critical points. Your critical points are going to be this function, whatever it is. You take the derivative and you set it equal to 0. And when I set my derivative equal to 0, is this a 2/3 and the 4? Okay, so this will be 2/3 and 4. Okay, right here. That's one way to do it. Then you go to your x function and find all of these values. Another way to do it would be to take the integral of the absolute value of your velocity function. Guys, make sure you understand. This has to be a function. It cannot be a number, dt, from t1 to t2. And so you guys tell me, I'll work it one way. Which way would you want me to work it? You want to do the table. Okay, so on the table, my x of t is this formula right here. So this is going to be equal to t cubed minus 7t squared plus 8t plus 5, okay? I'm just going to put that right into my calculator. Remember, if you make that your y1, you can generate your table. You actually have to turn on your calculator first. Okay, there we go. So I'm going to clear this stuff here. Okay, this is going to be x squared minus 7x squared. No, that's not x squared. It's x cubed. Okay, x cubed minus 7x squared plus 8x plus 5. Those of you guys doing the integral are probably laughing at me. Okay, those you're probably done already. Okay, so then I'm going to generate a table, and you can put in your own numbers, remember? So I'm going to do second table set. I'm going to start at 0, and I'm going to say, I'm going to change my auto to ask. I'm going to generate my own table. So second table, I'll put my table in here. 0, enter 2/3, enter 4, enter, and 5, enter. Okay, then you put all those numbers here. So that's going to be 5, 7.5185, -11, and -5. Okay, then you're going to get the differences here. The difference between 5 and 7.5185, I can see that already. That's 2.5185. The difference here, I can actually see that. That's actually just adding these numbers together. So that's 18.5185. And the difference here, I can see that between 11 and 5 on the number line. Is this 6, guys? I think that's right. Okay, I can actually do this without a calculator. But you guys, if you need a calculator, it's fine. You just punch it in. But these are just the differences here. Okay, the absolute value of the differences. You just need the positive number. So if 5 is on the number line and 7.5 is on the number line, what's the distance between them? Then you add all these numbers together. So it's going to be 2 point, and you're really not supposed to round, but I've gone a lot of decimal places here that I don't. You know what? Actually, if I go to my second table, I can get some more numbers. I don't know if you guys know this. If you just rest your cursor right there, does that make sense? You can see more numbers here. So that's 518. I can say 1852 if I want to. So there's, you know, if I wanted to add another number here, 2. Okay, so lost my train of thought. Okay, go to your home screen and then add all these numbers together. So 2.51852 plus 18.51852 plus 6, enter. And I'm getting 27.037, and you just need to go 3 decimal places. Anybody do it the other way and get the same answer? Okay, thank you, Emily. Okay, yeah, I could tell because you were done. Okay, so that is a way to get total distance. One way. The other way is just the integral of the absolute value, which works also, but you guys choose which way you want. Sometimes you have to do one or the other because you don't have enough data, okay? All right, is there a part E on this one? No, okay, so we're good. Okay, you guys are armed and dangerous. Finish up your homework if you haven't finished it up already. I'm gonna go around and check, guys, your homework from yesterday. Please have that out.